Okay, so the unfortunate timing here is that we are almost done with this unit, but we don't have enough time to take a test tomorrow. So we're gonna have to like take a 2-week break, and then when we come back, we'll try and kind of jog our memories, refresh, get a lot of practice. Then we'll take the test and all this stuff. But this is kind of the last thing we have to do in this unit. And it's called electron configuration. It's an important subject, and I think once you get the hang of it, you will find that it's pretty simple, pretty easy to get through. But the learning curve for this is a little steep. It's kind of, for me, it was difficult to pick up initially. Once I got it though, it was easy to get after that. So that's kind of the goal today and tomorrow, is to make sure that this is solidified for all of us, that we know how to do it really well. And then I won't have any worries when we come back from break. We can just, get some practice, kind of refresh our memories, and we will be really good to go. Okay, so page, I think it's page 5. This says page 6, but it's page 5. It is page 6? Oh, never mind, page 6. Right up here, it says electron arrangement. Okay, so we're gonna do this page today. We might get to page 7. We might be page 7 tomorrow, but the important thing is that we get page 6 done today. So I have a question. It's at the top of page 6. How are electrons arranged in atoms? Talk through tables. Think back to last unit. How are electrons arranged in atoms? Talk through tables. Go. Okay, Berkeley, how are electrons arranged in atoms? What do you mean by orbitals and probability cloud? Got to go more than that. What is a level? What do you mean? Okay. All right, I'll open it up. Who wants to help out? Go for it.
There's like different shells, and each shell has varying numbers of electrons.
Okay, so shells have different number of electrons. I'm okay with that. Yeah.
Well, they're like all over the place, but we don't actually know where any of them are because we can't.
Okay, we can't know where an electron is. We can only talk about, and I think Berkeley, this is what you were talking about, probability. We can't know where an electron is. We can only describe where it's likely to be. Okay, so on page 6, right up here, where it says misleading representation, I want you to draw, you can talk to your tables, draw a misleading representation of what an atom looks like and how electrons are organized. Page 6, we're drawing the misleading representation of what an atom and electrons look like. Brody, you got your study guide. Hey, Landon, describe what you drew.
I just drew like a circle and then another circle and then another circle.
And what do these circles mean? What do they represent?
Orbitals. Orbitals.
Okay, so are orbitals circular paths, kind of like planets around the sun? Is that what they look like? No, they don't, right? Orbitals do not look like little circular paths, and electrons don't move around the nucleus like a planet moves around the sun, okay? That is a misleading representation, okay? So diagrams that look like this, right? Or this, or even this, okay? These are misleading. This is not how electrons move. This is not what an atom looks like, okay? Give it a big fat nope, right? It is misleading, okay? Trey, what does an electron actually, or sorry, what does an atom actually look like? And what do these dots mean? So how do you represent in your picture like high probability versus low probability. Cool, okay, I'm okay with that. Sometimes if you want to use dots, you can. Other times we use they call it the cloud, right? And you represent a high density by shading it kind of darker, and you represent low density by shading it lighter. But if you wanted to use dots, that'd be fine. So in this region here, I would draw a whole bunch of dots that are close together. Whereas out here, I would draw dots that are pretty far apart. Now we have to remember that not every dot represents an individual electron. Rather, it just represents that this area is where an electron is more likely to be, and this area is where an electron is less likely to be. Okay, so if you draw the cloud or the dots, either way, okay, you just got to remember that this is the more accurate representation, whereas this is very misleading. Are we okay with this? All right, so all atoms have these electrons, and these electrons exist in certain places within this cloud. And these orbitals actually take on a variety of shapes and sizes. And what you're going to learn about today through a computer simulation is specifically what these orbitals look like. Some are spherical, some are more lobe shaped like this. You might even see some that are donut shaped. Okay? They come in these weird shapes and sizes. But we can give these orbitals names, we can know where they are, we can know about their energy levels if we learn the rules about electron configuration. Okay? By definition, an orbital is a three-dimensional region around the nucleus that indicates the probable location of an electron. And so here's a few examples of what they might look like. Okay? Some spherical ones here. These are more lobe shaped. These kind of have maybe a parabolic shape. And we've also got the weird donut ones too. Okay? This is what the computer simulation is going to look like. Okay, you're going to build some atoms that they're going to give you examples of. Okay, I will show you how to get here because it is kind of tricky to get here. Here's the URL for it. But the important thing as you go through this is, I would say the first thing you want to do is write down the number of electrons that each of these elements have. Should we do that together right now? Let's do it right now. Okay, find helium on the periodic table. How many electrons does helium have? How many? 2. I thought I heard many. 2. Okay. 2 electrons and a neutral atom of helium. What about carbon? Thank you. What about carbon? Everybody. 6. Okay. What about sodium? 11. Right. 11. And argon. 8, not 8. 18. Okay. It's got 8 valence electrons, but 18 total. Okay. So you know the total number. What you're going to do in this computer simulation is follow the rules that they give you and basically structure where these electrons would go. Okay. What you'll find is you're going to pretty often break a rule, and it's going to tell you, oh, you broke this rule, try again. Okay. And you're going to learn how these rules apply and where electrons go. The important thing though is you got to account for all the electrons. So don't try to put more than 2 electrons in a helium atom. Don't try to put more or less than 6 electrons in a carbon atom. Okay, that number there tells you when you're done, when you've filled up all the stuff you've got to fill up. Okay, this is what the boxes look like in the computer simulation. So you're gonna see this. I would highly encourage you though, once you've built it, to draw it as well. Okay. So build it in the computer, do the work, and then it'll say you're good, then draw it here. Okay, draw exactly what it looks like. It's not that hard to draw. That makes sense? That way you can come back and look at it later. Okay, for this particular thing, I would like you to try and work in pairs. Don't work in a group of 4, because if somebody can't see the screen, then they're at a huge disadvantage. So work in pairs and try to see the screen. If you're at a table of 3 and you want to work together, that's fine, but somebody's gonna have to move so everybody can see the screen. Okay. Again, the learning curve for how this works is kind of steep. It takes a little bit of practice to get used to it. Once you know how to do it, it's going to be really easy. And I think you'll see that by the end of the hour and into tomorrow. But we've got to make sure that we work hard at this first part so we get the rules down. Everybody okay with this? Okay, what I'm going to do now is I'm going to show you how to get to the activity, and then I'm gonna kind of turn you loose. You can go grab your Chromebooks and we can get started. So again, you gotta watch. You gotta watch. This is tricky to find. Hold up, don't talk. You gotta watch. This is tricky to get to. So you're gonna type in the URL. And you're gonna get a window that looks like this. Where does it say to go? After I type in the URL, where do I go? Select It's Elementary. Do you see where that is? I'm gonna click It's Elementary. Now what? Okay, do you see the drop down menu right here? I'm gonna click drop down and I'm gonna go to where? Activity building elements. Okay, you're gonna click on that and you're gonna click play. Okay, this is what it looks like. You're gonna start building the items. Are we okay with this? Okay, so send one person to go grab your Chromebook and get started. Okay. Again, try to work in pairs, don't work in a group of 4. Everybody got to see the screen.
Yeah.